Welcome back. In lesson 14.3, we are going to learn how to write proportions based off of word problems, and we're also going to be solving those proportions. So here are some reminders that you want to take a minute to copy down. So maybe push pause, copy it, and then push play, and you can hear me explain what these little notes are. Okay, so just a reminder, a proportion is an equation. It's going to have an equal sign stating that two ratios are equivalent. We're going to need to remember this old fact: a percent is a ratio out of 100. So 40% can be expressed as 40 over 100. That would be the ratio form. When we write proportions, we are going to use guiding words to make sure our proportion is set up correctly. And today you're going to learn two different ways to solve proportions. So you can simply use what you know about finding equivalent ratios or equivalent fractions and use multiplication or division. Or you can use cross products to solve, and I'll show you how to do that. Okay, these problems are kind of lengthy, so you'll have to listen. I'll just write down the key information to the problem instead of writing out the whole thing, at least for the first couple. So let's say there's a test and it's worth 50 points. And the test score, let's say, is 40%. Ouch, hopefully it wasn't a math test. And you want to know how many points did you score? So here's the information we're going to use to write a proportion, and then we're going to solve it. And you've already done this before in a ratio table. So you are completely set up. You know how to do this in a ratio table. We're just going to take away the outline of the table and just write it as a proportion. So let's talk about these guiding words. We know we have to figure out how many points, and we're given that it's out of a total of 50 points. Okay, so these are the guiding words that we're going to use to help make sure our proportion is set up correctly. So first thing we're going to tackle is our 40%. Okay, so 40 is a ratio, 40 out of 100. We know the test is out of 50 points, and we don't know what our score was. So we'll use a variable to represent that. This here is your proportion, okay? It is an equation stating these two ratios are equal. So one method you could use to solve is just finding the equivalent ratio through multiplication or division. So, and again, we've practiced this before. We've just done it in a table. How do we get from 100 to 50? We divide by 2. So what do we do to 40? We divide by 2. 40 divided by 2 is 20. So in this case, x equals 20. So you scored 20 points out of that 50 to get yourself a 40%. Okay, so we wrote a proportion and we solved it using equivalent ratios. Okay, let's try another one. Number 2. So now the information is going to be presented in a table. We'll call it points and shots. Maybe it's a basketball game. Maybe it's a hockey game. I don't know. So game 1 and game 2. Okay. So in game 1, this person scored 12 points and took 14 shots. In game 2, 18 points, and we don't know how many shots they took, so that's going to be called X. okay? So we don't have a proportion yet. We're assuming that the ratios of points to shots is equivalent for both games. So when we write a proportion, we'll start with our guiding word, points to shots. We'll just do that off to the side. Now this one is pretty easy because it comes given in a table already. So we'll set it up 12 to 14, have to have an equal sign in a proportion, equals 18 over x. Okay, so one thing I want to remind you before we work up on solving is that ratios are fractions and those can be reduced. So reduce if possible. You're gonna find it might be really helpful. So 12 and 14 can both be divided by 2 and we get the ratio 6 to 7, and that's still equivalent to 18 over x. And then we can go back to our old method and find our equivalent ratio. Okay, so 6 times 3 is 18, 7 times 3 makes 21, so x equals 21, and it's shots in this case. Okay, I probably should have labeled this points on number 1 now that I'm noticing. Okay, so we have our proportion here, here's our equation, and here's our solution. Okay, so let's try another one that's not in a table. Number 3. A school requires, so you may want to write this with me, it's going to take a minute. 2 computers for every, ooh, I smell a ratio, 5 students. Write a proportion. That gives the number of computers for 145 students. Okay, so we're given a word problem and it tells us right here 2 computers for every 5 students. So there's our first ratio, but let's set up those guiding words off to the side. The numbers represent computers and students. Okay, so that'll just stay off to the side. Then we can write our proportion. So we're gonna have 2 ratios that are equivalent. Okay, start with the first information given. 2 computers for every 5 students. We don't know the number of computers. Number of computers we don't know. We can call that C or X, or you choose the variable, for 145 students. So here's our ratio, or here's our proportion right here. And you can use, again, equivalent ratios to solve. Okay, so if you don't know how many times 5 will go into 145, just work out the division off to the side. Sometimes we have to do that. Okay, so 5 goes into 14 twice. At 10, subtract, I get 4. 5 into 45, 9 times evenly. Okay, so C equals 29 computers. So we wrote our proportion and then we solved it. Okay, let's try a few more that aren't set up as word problems. They're just given as straight up proportions that we have to solve. Okay, and then we'll be done. So we have 14 over 35 as our first ratio that's equivalent to 18 over x. Now, we can't multiply 14 by anything to get to 18, but here is a reminder, and I wrote this earlier. if possible, reduce the ratio. It's gonna make your life so much easier. These are both divisible by 7. So 14/35 can reduce to 2/5. Drop in the second half of your proportion, and now look how easy it becomes to solve. Okay, 2 times 9 gets us to 18. 5 times 9, 45. So x equals 45. Okay, so reduce, reduce, reduce if possible. It won't always be possible, but it's always good to check. Okay, number 5. A to 36 is equal to 15 to 27. What do you want to do first? How do you get from 27 to 36? I don't know either. So look at your ratio, 15 and 27. Look at these numbers. What can you divide by? This ratio can be reduced. Divide them by 3. 15 by 3 is 5. 27 by 3 is 9. Drop in the rest of that proportion. Okay? So then we ask ourselves, how do we get from 9 to 36? Times by 4. What do we do to the 5? The same thing, times by 4. 5 times 4 is 20. So A equals 20. Okay, so these are really good lessons that you need to reduce if possible. Number 6, tune in, this one's different. Okay, so let's look here. If we have something like x over 7 equals, I don't know, let's say 2 over 11. That's not gonna look very pretty. So this is already reduced. Nothing I can do to get multiplication or division to help me. Okay, I don't know what to multiply by. I don't know how I get from 7 or 11 to 7. I don't know what to do to the 2. Okay, so if your ratios are already reduced and you don't know what to multiply by, use cross products. Okay, I mean, you can use cross products anytime if you feel comfortable with it, but this is a really good example of when to do it. Okay, so when we do cross products, remember, if there's an equal sign in between, the cross products will automatically be equal. Okay, and I'm just gonna write them underneath because I don't really have room to work out an equation up here. You'll see what I mean. 7 times 2 is 14. That's one of our cross products. Our second cross product, 11 times x, 11x. And if the ratios are equal, their cross products are equal. Oof, Dee, that is not very pretty. I don't want to work it out as much as you don't either, okay? So then, what's the inverse of multiplying by 11? Divide by 11. Divide by 11. The 11s cancel. Whatever 14 divided by 11 is, that's our value for x. So let's just take a little peek, okay? 11 goes into 14 once. At 11, subtract, I get 3, bring down. 11 goes into 30 twice. At 22, subtract, I get 8, bring down. 11 goes into 80 7 times. At 77, subtract, bring down. 11 goes into 30 twice. If you see a pattern, great. If not, you can simply round to the hundredths place, and it's about, that's what the squiggly line means, 1.27. Aren't you glad we use cross products? Okay, let's just try one more with cross products. I'll try not to make it as icky as this one. So 2/5 is equivalent to x over 32. So again, I don't know what I have to multiply 5 by to get to 32. This is already reduced, so now would be a really good time to use cross products, okay? So again, cross products have to be equal if the ratios are equal. And I'm gonna, instead of writing it up here like we've done before with equivalent fractions, I'm gonna write it underneath so I have room to work out the equation. 5 times x is 5x. The other cross product, 2 times 32 is 64. Cross products have to be equal if those ratios are equal. In order to solve, divide by 5, divide by 5. 64 divided by 5. 5 goes to 6 once. At 5, subtract, I get 1. 5 into 14 twice. At 10, subtract, I get 4. Decimal, hop, 0, bring down. 5 into 40 evenly, 8 times. So x equals 12.8. Okay, that completes our lesson.